All right, so yesterday, whenever we talked about law of sines, we had at least two angles and then one side. Whereas we set up the proportion, remember that it does not matter as far as what goes in the numerator spot, what goes in the denominator spot. Okay, as long as all the way across, if you keep it as all the angles, all sine of the angles that you're using over the side, the opposite side on the bottom, or vice versa. Okay, now whenever we had two angles and a side, okay, angle side angle, side angle angle, or angle angle side, whatever you want to call it, it was always easier because you could find the third angle, and then you could just go with the with your proportion and work that way. Whereas today you're going to have the ambiguous case. Okay, ambiguous case means that you're going to have two sides and an angle. Okay, we go side angle because we don't want to flip it around because we don't want to make it a bad word. Okay. No need for that. No bad words in trig or PreCalc or whatever you want to call this. Okay? So with that, you're going to have different types of results that can come up. Okay? You can have one triangle where like A is greater, so one side is greater than your height. Okay? And it's also greater than another side. Okay? You're going to have one triangle. You could have a right triangle where A and H are the same, so one of your angles are the same height or same length as your height. Okay? And then you could have no triangle. So where in some cases that there's no possible way, remember, the angles have to go in order of side length. So like your lowest angle, the opposite side better be your lowest length of side. And then you could also have two triangles to where you have to work there. And like in this case, you have two sides that have the same length. That doesn't necessarily mean, okay, depending on how it works or where it's at, it doesn't necessarily mean that they are the same angle measurement. Okay, in the case that's up here, it is the same angle measurement because it's an isosceles triangle. So then here on example 2. So you have a triangle, it's a solved triangle ABC, round your side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so what I want to do first, where yesterday, like I told you, we're always going to use the same value. Okay, whereas here you are, I guess we only have to find C. We have B. We need to find the other angle measurements. So the one that I do have is, at first, I have certain parts that I can use. Okay, I have that 81 is going to be over sine of 43 degrees. Then I know that I have side length B of 62, but I don't know what the angle measurement is for angle B. And then lastly, I know absolutely nothing about side C or about angle C. Okay? So what's the order in which that can I solve for either side C or angle C right now? No. I have to at least have 3 of the 4 parts, okay, somehow, some way. So what's going to be the first thing that I'm going to need to solve for? Angle B, right? So the first thing that I need to solve for is using these 4 parts, or really 2, there. So I'm still going to do everything the same way. I'm still going to cross multiply and have 62 times sine of 43. So 62 sine of 43, again making sure that I'm in degree mode. So whenever I type that in, it's like 42.283898832. Divide that by 81. That gives me a... So after I divide by the 81 here, okay, it gives me a value of, and I can show you this through the calculator, okay. So whenever I do this, okay, it gives me a decimal of like 0.5220. So like how this is going to look on the calculator is it's going to be 62, I'm still in degree mode, that's good, 62 sine of 43. So I got that. Then we divided by just regular 81. Okay, but I get this decimal. Okay, I still have to find an angle. So if I have a value, okay, it's not 0.52 degrees. Okay, I still need to find its sine of this value, sine of angle B. Okay, sine of angle B is equal to the 0.522023436 and all that jazz. Okay, but I've got to go back and have, it's basically like I have my fraction, I have my side links, and I need to find the actual angle. So all I'm going to do from here, if I'm finding the angle, I'm going to go second sine, and I'm going to go second answer. And I'm going to put this value, okay, I don't just type in 0.522 or 0.5 or 0.52. Okay, I'm going to take the whole answer because even though I can't see all this stuff that's back here, okay, the calculator still knows that that number keeps going on and on. It just can only fit certain numbers in the window. I'm going to close the parenthesis, and then it's going to give me an angle of about 31, I'm going to say 31.47. Okay, I'm going to round it. If you round it to 1, what did it say? Did it say to round it to the nearest tenth or hundredth? I can't remember. We'll look. Nearest degree. So we'll just call it 31 then. Okay. So if it's nearest degree, we'll say 31, and we'll go back here to what we just did, where we had angle B was about 31 degrees. So now from what we have, again, it's about 31, so we had 81 over sine of, what was it, 43? Now we have 62 over sine of that 31. What is that going to make my angle C then? 106? So how did we get the 106? Yep. 180 minus 43 minus 31. It got us the 106. So now we can go and we can find sine of 106 degrees. Now we can find angle C. Again, I would still use this value with our new angle measurement because we rounded the 31. So I'm just going to basically set everything up from here and go 81 over sine of 43 degrees. C sine of 106 degrees, and then cross multiply. So 81 times, it just becomes like we did yesterday, 81 times sine of 106 divided by sine of 43, and we get a length of 114.2. Now, next problem is where you're going to have no solution. Okay, so it says solve triangle ABC if A, is 75 degrees and if angle A is 75 degrees, your side length there is 51 and B is 71. So if I don't have a picture, I don't have a triangle, I can draw one if I want. That's completely up to you. Okay? If we go about this, what's the first, like with the information that I'm given, what do I need to find first, obviously? Like I have angle A, I have side A, I have side B. What's the first thing in the order of which I need to solve? Angle B, right? So if I just do sine of 75 degrees over 51 equal to sine of B over 71. Now, why do you think we would have no solution? What would make us not have a value for, what would make this untrue or not a triangle or no solution?
All the degrees inside are above. Oh, that one.
Yeah. What do we know about the relationship of the angles to the side lengths? They have to be what? They have to go in order, right? Okay. Most likely, since this one's no solution, it's probably not going to happen. So if we go to our calculator, so I'm going to back out of this and go to here. So I have sine of 75 times 71 divided by the 51. So I get my 1.344 all this value. Do the same thing just like I did before and go second and here and go second answer. Now why is it going to give me a no solution? Where do your sine values have to lay or lie between? Between what two numbers? You remember? What was the highest point? What was the lowest point whenever we had like a graph of a sine function? 1 and negative 1. What's the problem with this number right here? It's above 1. Okay? So whenever you put this in, and whenever we close that off and we hit enter, it's going to give us a value. Okay? You entered, the value you entered is not allowed in the function or command. Basically because it's outside of our window. Okay? Because for all of these things to be true, it's not going to complete a triangle is what's going to happen. Okay? Because that opposite side is only 51 or whatever it was in length, okay, is where our problem lies. Okay? Because it's only 51, if B is 71, then that side B better be pretty darn big. Okay? And C's never, it's basically going to look something like this here. And then it's going to go up. So let's say that that's 75. 75 degrees. And then if A is 51, it may only get to there. Because B is 71, it's not going to reach. Okay? Because everything's too steep. It's never going to get there. Okay? Now, the last one is you have a triangle, you have sine, or you have 40 degrees, and then you have A is 54, B is 62, round your side lengths to the nearest tenth, and angle measurements to the nearest degree. So, what happens here is if I have sine of 40 degrees over 54 equal to sine of angle B equal to 62. So sine of 40 times 62 divided by 54. So from here, if I need to go back through the calculator so you can see what to do, or you're good there. Okay, so I go through everything. Sine of 40 times 62, divide by 54, I get 0.73801, all this jazz, and then plug it back in. I get an angle measurement of angle B is about 48 degrees. Okay, 47.56, we'll round it to the nearest degree. Okay. If we find angle or side C, angle C. Okay. So if we deal with sine of C, if we know that this is 48 degrees, what's angle C going to be? 92 degrees. Okay. So this is 92 degrees. I'm going to take these two here and here. Okay, so if I have sine of 40 over 54 equal to sine of 48 over C. Oh, not 48, my fault. 92. Multiply, divide. So, sine of 92 times 54, divide by sine of 40. I get a length of 83, well, it'd actually be 84. Now, what happens is if I would do the same thing but do it with these values, okay, is if I would use sine of 48, not sine of 48, but 62 times sine of 92, and I divide by sine of 48, I get about the same thing. And the last thing here, and you need to, I believe this is not on your, it is not on your reference sheet. I would put this somewhere like above law of sines or below, kind of in that open space, where it talks about the area of an oblique triangle. So whenever we talk about the area of an oblique triangle, remember we have area of a triangle is 1/2 base times height. Okay. If you have two side lengths and one angle, you can always find the area of a triangle. Okay. It doesn't necessarily, you don't necessarily have to have the height. But with the two side lengths that you're given, and if you're given the other angle. So basically the two sides that make up a single angle. Okay, does that make sense? So like if I would draw this, and it doesn't necessarily have to look this exact same, but if I have a triangle here, okay, if there's A and then here's B, okay, if in any order I have the two sides that make up the two angles, or if I do it like A to B to C like that, or if we go with B to C here. Okay, so any of the two sides that make up the angle that I'm given, okay, I can find the actual area of my triangle. Okay, I don't necessarily, it's kind of a busted myth from what you've always been taught that you have to have the height. You don't have to have the height anymore. Okay, as long as you have two sides that make up an angle, you can still find the height of your the area of your triangle. Okay, it'll always tell you that it's an included angle. That's not going to be any different.